So now let's look at chi-square test of homogeneity. So the goodness of fit test can help you decide if one population fits a given distribution, but it won't let you do two populations. Well, the test that you can run for those two populations is a test for homogeneity, and it can be used to draw a conclusion about whether two populations have the same distribution. So to calculate the test statistic for the test of homogeneity, we do the same thing that we did for the test of independence. There's slight differences, but it's not too bad. Okay, so our hypotheses are different, but to me they're a little bit easier. So the null is the distribution of the two populations are the same, and the alternative is the distributions of the two populations are not the same. You're going to use a chi-square test statistic. It's computed the same way as the test of independence. But remember, we didn't need to worry about that because Minitab did everything for us. Degrees of freedom is number of columns minus 1. Don't even need to worry about that. Minitab does it for us. So again, all your values in your table have to be greater than or equal to 5. If not, you have to do a Fisher's test. And then common uses that we use this, if we're comparing men versus women, before versus after, east versus west, those kind of things. And again, this is if I'm not using means, I'm using proportions. That's the huge thing about chi-squared, or I'm using counts. Again, I'm not using averages in any way. So the variable is categorical with more than two possible response values. Okay. So here's the example. Do male and female college students have the same distribution of living arrangements? Use a level of significance for 0.05. So think about this. At a residential college, I need to know how many female or male dorms I need to have if I'm going to do my room assignment by gender. So here's one way that they compare that. Suppose that 250 randomly selected male college students and 300 randomly selected female college students were asked about their living arrangements. So they were asked, do they live in a dorm? Do you live in an apartment? Do you live with your parents or other? So here we go. I'm going to show you the results. Oops. Let me show you the table. Here's the table. Okay. So again, I have 72 males that live in the dorm, 91 females that live in a dorm, and so on. You can see how many live in an apartment with parents and other. So again, what's going on with here? I'm comparing males versus females in the 4 different ways that they live. Okay, let's go back and look at those hypotheses. Okay, the null is the distribution of living arrangements for male college students is the same as the distribution of living arrangements for female college students. The alternative is the distribution of living arrangements for male college students is not the same as the distribution of living arrangement for female college students. So again, I did this by hand. Degrees of freedom is 3. I don't want you to do that. I want you to use Minitab. So much easier. All right. Again, I said we're going to do everything like we did when we did the chi-squared independence. All right. So let me show you what I did. I have my stuff here. I put my stuff in. I just didn't put my rows. I mean, you could put here male, female, if it makes you feel better. It's up to you. Just make sure not to include it because it's going to get mad if you do. Okay. I'm going to go to tables, chi-squared test of associate. Okay, I already had old data in there. I'm going to get rid of it. So now I'm going to put dorm, apartments, with parents, and other. And then I hit OK. All right, again, it gives me the observed and the expected. It gives me the totals in each way. So again, these totals for dorm, 163 males and females live in the dorm. Apartments 170. I don't even have to do it by hand. It gives it to me, which is great. All right, I keep going down and look. Pearson, chi-squared, 10.129. Degrees of freedom is 3, and my p-value is 0.018. Okay, so let's go back here and look. I've already done everything. Again, I'm not going to use likelihood. I'm going to use Pearson. All right, so there's everything like I did for independence. I have my test statistic. I have my distribution, chi-squared with the 3 for the degrees of freedom. And if I go back here, remember, it gave me it right there. Didn't have to do a thing. Okay, p-value and my conclusion. Since I wasn't given a level of significance, I'm going to assume it's 0.5. The p-value is, let me make sure my p-value. Oh no, my p-value, I've got to update this slide. Okay, my p-value is, I didn't do it right there, but I did it right there. Okay, is 0.018. Okay, because 0.018 is less than 0.05, and again, if that confuses you, just add another 0. So now I can see 18 is less than 50. So it's a true statement, so I reject my null. That means at the 5% level of significance from the data, there is sufficient evidence to conclude that the distribution of living arrangements for male and female college students are not the same. Okay, so that means those two distributions are different. So I compared males versus females on different things to see where they lived. And I had 4 different categories of where they could live. This is where this comes in handy. So think about this way. If you're working in a hospital, you could do cardiac versus cancer patients and what type of rooms they use. Are they in a single, are they in a double, or are they in like ICU in a bigger ward? Those kind of things. Logistics, you have 2 trucking companies. You could say how many, you could do south, north, east, and west to see, do they have the same distribution of packages getting delivered? That kind of thing will help you with this kind of test.